Hi, one last experiment, and we are going to perform the experiment 9 part C. I just looked at the schedule, and we have been offering only part C of this experiment in the lab, so I'm going to perform only part C of the experiment. And when it does change in the future, if the schedule changes, then I'm gonna add the other parts to it. But for part C, and this experiment about electrochemistry. When you say electrochemistry, is like a chemical reaction that generates electricity or electron current. So you will get electrons being produced in one side or by one element, and electrons is being consumed by another element. That's what's happening in the oxidation reduction reaction. So in the electrolytic cell, we are going to use the source of energy, which is the battery that we are using. And we are trying to see if we have a solution of, we have choice of 4 solutions, and we want to determine which one is being oxidized, which is being reduced, and what is happening when we add solution of NaCl, copper sulfate, potassium iodide, or sodium bromide. We are looking for evidence for the reaction. Let me show you the document for this experiment, please, specifically for part C of the experiment. So based on the background, the reduction and oxidation in chemistry means that the oxidation, when element is losing electron, or oxidation number has increased. So zinc in this case has been oxidized to zinc 2 plus. Oxidation number has increased. Electrons are produced. Electrons appear on the right side of the equation. That's on the product side of the equation. So that means electrons have been produced. So this is an oxidation half reaction. In reduction half reaction, electrons appear on the reactant side. Zinc 2 plus has oxidation number of 2. Zinc solid has oxidation number of 0. So from 2 plus going down to 0, that means oxidation number has been reduced. So we have reduction taking place. So we have oxidation half and we have reduction half. This is an example of reduction half. So we have reduction taking place because electrons are on the reactant side. We also want to know about cathode and anode. What is happening in cathode? Cathode is a place that reduction takes place, and anode is where the oxidation takes place. So in any side that you see reduction taking place, that side is going to be cathode. That means electrons are moving toward that. And oxidation, anode takes place in anode, and in the anode side, electrons are being produced. For a voltaic cell, like we have the picture here, we also use a salt bridge. But the salt bridge is going to make up with the lost electrons or gained electron, the balancing of the charge. So if you have potassium nitrate, any area, so in the cathode side where electrons is being consumed, then you have to bring in NO3 minus. In the anode side, when the electrons are being produced, you have to bring like K plus in order to balance the charges. And when you have like a voltmeter here, direction on the voltmeter where the electrons are moving is going to be shown also by using the voltmeter, or you could see that electrons are being transferred from one to the other cell. Cell potential It shows the activity or reactivity of the metals. Basically, the metals that they can give electrons easier, they have higher potential, or they have more metallic properties. For part C of the experiment, which is the electrolytic cell, the setup is going to be like a U-shaped glass tube. We are going to put two graphites connected to the battery, and then we place a solution. We apply basically energy from the battery, and we want to see if we have sodium chloride, what is going to be oxidized, what is going to be reduced. And then we have the choices. So when you read the manual, it gives you the choices. For sodium chloride, it gives you choices, and you look for evidence for either oxidation or evidence for reduction. If one is oxidized, the other one is going to be reduced. So I'm going to explain just a little bit more about this reaction when you have sodium chloride. When you have sodium chloride, you have sodium ion, and is in the solution, and you have water. The negative ones, or the ones that being oxidized, it could be Cl minus or water. What happens if water is oxidized? I'm sorry, if water is reduced. If water gains electrons, is going to change to hydrogen ion and hydroxide ion. We already know our friend phenolphthalein. So if we add phenolphthalein to the tube, the side that hydroxide ion is going to be produced is going to be the one that it turns to pink color. So if you see like no pink color in the solution or in either side of the tube, then you can say water has not been reduced because there was no hydroxide, with the condition that you don't forget to add the phenolphthalein. Because if you don't add the phenolphthalein, you cannot see the hydroxide ion. If you have, in one of the experiments, if you have the water being reduced, that means hydroxide ion has been produced, then water has been reduced, so water cannot be oxidized. Water is going to either be reduced or is going to be oxidized. So if you see the hydroxide ion produced by evidence of pink color, then from these two choices, you pick H2O plus electron, giving hydroxide ion and H2. This goes to the reduction half. What happens, where does the reduction takes place? That's in cathodes. So on the report sheet, you are going to write this equation, only this equation. Out of the two choices that you have, you only write this one. Don't write this or that. This or that is before you perform the experiment or before you watch the video. If you see the pink color appears with addition of the sodium chloride, this is for the sodium chloride only, pink color appears, then you would say water has been reduced. So you write this half reaction only this half reaction only in this half reaction only in the cathode side, and you say water has been reduced. Then you look for the other side. You have two choices: either chlorine being oxidized, chloride ion being oxidized to chlorine and gives electrons, or water has been oxidized. So since we already saw water has been reduced, we cannot say that water is being oxidized and reduced. So what's happening to the Cl minus? The evidence for this reaction is that a smell of chlorine or yellow color, because chlorine is gas and it has a yellow color. So you have to evidence one of them, okay? You could see either the yellow color or the smell of the chlorine gas in order to decide that chlorine has been oxidized. When you decide that chlorine has been oxidized, then you put the check mark here for yourself as a note. Then when you go to your data sheet, you write this reaction in the cathode side as a half reaction for reduction. And this reaction, the top reaction for Cl minus giving Cl2, as the oxidation half in the anode side. And then your observation is going to be recorded when I perform the experiment. So you're going to record the experiment, the observation as I record the, I perform the experiment. After that, you're going to use the Ki solution. And then for Ki solution, you have two choices, K plus or water to be reduced. Then you have a choice of I minus and H2O to be oxidized. Very similarly, you are going to look for evidence reaction. If the OH minus has been produced, then if it is produced, then you could say this is going to be. If OH is not produced, then you would say this one. I'm not going to say which one. You have to figure out from the evidence for the reaction. Then for anode side, between these two, which one is going to be the reaction? So if water is, again, reduced, then most likely iodine is going to be oxidized. And if the other one, then water is going to be oxidized. So I'm going to start performing the experiment. And as usual, I use my lab manual for performing the experiment. This is for part C of the procedure. Okay. For part C of the experiment, first of all, I need to set up the electrolytic cell, which is the U-shaped glass tube. I'm using a battery, using this connecting tube. One side is going to be my graphite connected and staying on one side, and the other side is going to attach to the battery. And the other one, I take a different clip, and one side stays in the usually when we have too many students here, we don't have much of a choice. We have to deal with it, but now I have plenty, and it's only me here. And then the other side is going to be attached to the battery. So you see, it's a very simple setup of the electrolytic cell, and I need to connect it. So first, I'm going to add the 2% solution of sodium chloride. So that's for the first one. I'm going to add the 2% solution of sodium chloride. This is my 2% sodium chloride solution. Add phenolphthalein to each side, so in case if OH formed, I could see that. One drop should have been enough, just too many. So. Oh. This one. I want to mix it so you could see, start with the clear solution. So in case if there is a color change, you see it more obvious. Going to connect to the battery. And wait. If nothing happens, it could be that the battery is dead. But what do you see here? Do you see any pink color appearing? Okay. See, the pink color appeared on the left side, on this side. So I know if the pink color appears, what does it mean? I explain more about the first experiment, then I expect you to think about the other experiments. So when the pink color appears, that means hydroxide ion has been produced. So I go back to lab manual and says, what does it mean hydroxide ion has been produced? That means that water has gained electron and produced hydroxide ion. So on this side is going to be on this side. So water is reduced. What's being oxidized is not going to be water. Water is either reduced or oxidized, unless we are trying to get the unless we're electrolyzing only water to get only hydrogen gas and oxygen gas. So water is being reduced. So on the other side, we have only one choice then left, that is chlorine. Chlorine has been oxidized. The smell of the odor of the chlorine is very obvious here, but since you are not here to test for the odor yourself, you're going to trust me, the odor of the chlorine is here. And also, you don't have much of a choice because the water we already know is reduced. So water cannot be oxidized. Cl minus has been oxidized to give you Cl2. And the smell and the choice is going to indicate that in the anode area, this is the anode now, and in the anode, the chloride has been oxidized to chlorine. Okay, I'm going to take these out. I also disconnected. I'm going to wash these using DI water to get ready for the next experiment. Going to wash the electrodes. Going to remove the U-shaped glass tube. That was for the first experiment. Replace it with a new one. You can wash it or replace it, depends on how many of those you have available at the time. Your second experiment. Your second experiment is going to be copper sulfate. So we're going to test for copper sulfate. So you have two choices. One is Cu plus, Cu2 plus, or water. On the other side is going to be SO4 2 minus or water. And then if water has been reduced, we will see pink color. Going to connect and wait. I have to wait until I see a different change. Either a pink color should appear, or if copper has been reduced, I should see like dots of the cupric color, red colored dots on the graphite. So for that, I have to wait. Not going to happen right away. I give the reaction some time. Okay. I don't see the pink color. I'm going to give some more time because I have to wait until something happens so I can show it to you. Just waiting. Nothing is being done really. Just waiting for the reaction. Doesn't show expiration date. 2015 is. Okay, good enough. Very good. That's all I was looking for. Okay. The tip, the end of this graphite, it has red dots. And what does the red dot means? It means that the red dots on it, it means copper has been reduced. So Cu plus has changed to Cu2 plus has changed to Cu solid because we have those dots there. And as a result, copper has been reduced. If copper has been reduced, of course, water is not reduced. So I don't expect to see the phenolphthalein color change. So this part of the experiment, water has been oxidized, copper has been reduced. Okay? Copper, how do I know water has been oxidized? Because there are some bubbles that formed on the anode. Those bubbles that it formed on the anode, when I take it out, the bubbles break and you can't see it, but they bring you closer if you can see the bubbles. If not, you have to trust me. Bubbles formed, or write it down. Bubbles formed around this anode. Bubbles formed that would be the oxygen gas that is being produced, and red dots formed around the cathode electrodes. So in the cathode electrode, red dots have formed. I could see, and I showed you, there aren't like very, very like bright red, but it's a red dot sitting on the graphite. And then this one, bubbles have formed, and more bubbles are forming. If you bring, I'm going to bring it closer. Hopefully you can see the around the electrode, the graphite. We see those little bubbles that are forming. Okay, so this, I'm going to stop this experiment of copper sulfate, move to the next experiment, or the next solution, which is the Ki. So to change the tube, or U-shaped glass tube, to fill this one, the new one with so for NaCl, water was reduced, Cl minus was oxidized. For CuSO4, copper was reduced and water was oxidized. For Ki, I'm going to add a drop. I'm going to add just one drop. And place the electrodes. Connect to the battery and look for evidence. Okay. So at least we know the battery is working. Look. See the pink color? The pink color appeared. The white background, you could see the pink color better. So the pink color appeared there. What does that mean? The pink color appeared in this electrode. This electrode is the cathode. What is being reduced is water. And on this side, a yellow color. See, the yellow color is being produced. And that yellow color is the color of iodine. See, it's very obvious yellow color. And iodine I2, that means iodide has been oxidized. I'm going to stop the reaction because all we want to do, look for the evidence that what has been reduced, what has been oxidized. So if you look at these two sides of the tube, we see the pink color. That shows OH minus has been produced. That means water has been reduced. That's happening in the cathode. And on the right side, or this side, you have the yellow color of iodine being produced. We have one more experiment, and that is the KBr. So I'm going to fill the next tube with the KBr solution. add 1 drop of phenolphthalein. Trying to mix it. Wash the electrodes. And place in the water. Okay. We're looking for KBr. Water has been BR solution. The BR solution, we have the sodium bromide. Sodium bromide, pink color already appeared, and that means we have the color of phenolphthalein changing. Hydroxide has been produced, and when hydroxide is produced, that means the water has been reduced. Water has been reduced to hydroxide. And on that side, water has been reduced. On this side, a pale yellow color, very light yellow color has been produced, and that is coming from bromine. It's coming from formation of bromine. So water has been reduced and bromide has been oxidized. Okay. See, there's a difference in color on top and the bottom. So it's a pale yellow color that has been produced here for bromine, and then the pink color is for hydroxide ion. So for NABR, bromine has been bromide has been oxidized. So these are the result of the experiment, the evidences for your experiment for oxidation reduction. What's your responsibility? To determine which one has been oxidized, which one has been reduced, and then find out which half reaction goes to the oxidation half, which half reaction goes to reduction half. You do have more than one choices though. You have choices there for the oxidation, 2 choices for oxidation. One of the choices is always water, and based on the evidence of the reaction, you are going to decide which one actually took place. Okay. The experiment 9, because it's just part C of the experiment, is kind of short, and we are done with the experiment. Record your observation, fill out the data sheet for submission as an assignment. Thank you. And this was the last experiment for 1046.